been a very long time since we had lessons. Thanks be to God, we are currently back gradually. We will soon resume with the board. But today, as we have it here, we want to look at the solutions of the BECE 2025. So we are beginning with the question 1. And with the question 1, I read, says that 2, which is x is such that 1 is less than x, less or equal to 20, where x is a counting number. And we are to list the members of P intersection Q and list all the subsets in P intersection Q. That is for the A. And the B says if you have 1 over y is equal to 3k minus 2 over x, make y the subject of the relation. And you are to use your result in B, I, to find the value of y when x is equal to -1 and k is equal to positive 2. Good. So with this question, let's try to look at the solution that was required from us. Let's see what was needed from candidates on the examination day. So with this question, we have already solved. So I will just explain the steps involved and what best was expected of us. So looking at the question that I just read, how best are we supposed to solve this question? So coming to the solution, you see, we were first asked to list the members of P intersection Q. Now, before we can list the members of P intersection Q, 1 is less than x and less than 20. This was what you were given, where x is a counting number. So looking at the range of x that you have been given 1 is less than x, less or equal to 20. So we are listing the counting numbers beginning from 2 because it is less than 1. So if it is less than 1, then it means we should not include 1 in the listing of the numbers. So when you look at the universal set, we started from 2 and it is a counting number. So we have 2, it should be less or equal to 20. So if it is less or equal to 20, then this is what is expected or was expected from candidate to list for the universal set. Then we have P. P is also saying that P is a multiples of 3. Now this P, multiples of 3 usually begins from 3 to infinity. But here we have been told that the P and the Q, they are subsets of the universal set. So what it means is that when we list the element of P, we should not exceed more than the element in the universal set. So when you look at the element that we've listed for P, we have 3, 6, 9, 12, 15, 18. And these are the multiples of 3. So 3, 1, 3, 3, 2, 6, 3, 3, 9, 3, 4, 12, 3, 5, 15, 3, 6, 18. Now 3, 7 is 21. But since 21 is not in the universal set, we will not include 21. Because P is a subset of the universal set. Likewise, the Q. Q is also the subset or a subset of the universal set. Please, I hope we are following. Good. So if Q, we have been given here that Q are positive even numbers, then what we should know is that we should list all positive even numbers that can be found or happens to be a subset of the universal set. So without including the element that cannot be found in the universal set. So if you look at the listed numbers here or element here, we have 2, 4, 6 up to 20. because these numbers can be found in the universal set. So now that we've been able to list the element for the universal set, the P and the Q, we can now answer the question that says we are to list the members in P intersection Q. Listing P intersection Q. So P intersection Q, what does it mean? It simply means element that can be found in P again can be found in Q. So when you look at it carefully, we have 6 in Q, we have 12 in both, we have 18 also in both. So this gives you the what? The P intersection N to be 6, 12, and 18. Good. So this is what was expected from candidates when they were writing the mathematics for the question 1 AI. Then the II is saying list all the subsets in P intersection Q. Now here we have been asked to list the subset, and first of all we have to know what the subset is. So a subset we can simply define is a set that can be derived from the main set. So this P intersection Q, we want to know the number of sets that we can derive from this given set. So we have 6, 12, and 18. Now, when it comes to subset, listing or writing the members of a given set, we should know that a null set is a subset of every set, and the subset is the element or the set is a subset of itself. So a null set is simply a set without any element. So we have the first one here. Then the last one here, you have the same set being a subset of the set. Good. Now let's look at the number of subsets here. We have been asked to list all the subsets. Okay, we said we should list all the subsets. But I normally advise students that before you list all the subsets, you have to know the number of subsets we need. Okay, or the total number of subsets that we can get from listing the subset. So we can know the number of subsets by simply using the formula 2 raised to the power n is equal to 2 raised to the power 3. And this would simply be 8 because 2 raised to the power 3 is giving you 8. So when we list the subset of P intersection Q, we should get 8 members. 8 members. So we first of all begin with a null set. Then we list each element as an independent set because they can be found in the main set. So we have 6, we have 12, we have 18. Then we begin to pair 6 and 12, 6 and 18, then 12 and 18. Then so the solution we have here, the question 1 AII and that of II or I and II, this was what was required from learners, that they should be able to list the universal set, list the element of P, list the element of Q before they can find the intersection. But you see, all this one was hidden, or it was hidden. So the learner should be able to list all this in order to be able to find the P intersection. The learner is supposed to list the possible set that can be derived from P intersection Q, the number of subsets that can be derived from P intersection Q. So when you look at it carefully, before we can list the subset, let us know the number of subsets that can be derived from the set. So that is why we briefly did this calculation here, for us to know the number or the number of members or number of elements we need to form the subset. Good. Then let's go to the B. The B, as I read on, says if you have 1 over y is equal to 3k minus 2 divided by x, we have to make y the subject. We have to make y the subject. Let's look at how the solution for this one also goes and what we were being demanded of. Now, when you look at it carefully, you have 1 over y is equal to 3k minus 2 divided by x. We have to make y the subject, and this is a fraction or an equation involving fractions. So having an equation involving fraction, we have to first of all know the LCM. So looking at the first one, the 3k, we can say it can be divided by 1. And the LCM for y, 1 and x is xy. That is the LCM. So now that we have the LCM, we will use the LCM to each of the terms by the LCM. And the LCM is xy. So we multiply the first term, which is 1 divided by y, by the LCM. We also multiply 3k by the LCM, and we multiply 2 divided by x by the LCM. So when we do the multiplication, we will notice that, or we can notice that y can cancel out. So y will cancel y, leaving behind x. And when you come here, x will cancel x, leaving behind y. So after cancelling, we can multiply and say x times 1 will give you what? X. And multiplying xy times 3k will give you 3kxy minus 2y. 2y because x has cancelled x here, and we are left with y times 2, giving you 2y. Now, having this as the expression, we have x is equal to 3kxy minus 2y. This is the expression we now have after eliminating the fraction in the equation. When you come here, you can see that we've done something here. What have we done here? We've done factorization, or we have factored the common number or factor out. If you look at this expression, we were asked to make y the subject, not x. So if x is the subject, then what can we do in order to make y rather being the subject? And we know that letting a variable be a subject is simply by letting that variable standing alone on one side of the equation. So you have x is equal to 3kxy minus 2y. We first of all, we have to factorize, because in this term we have y, and in this term we also have y. So if we factor y out from both, we are going to get y to be out from this term and y to be also out from this term. Good. Then you have 3kx, y is out. You are left with 3kx. Sorry, you are having 3kxy, and you have factored the y out. So we have x 3kx minus 2. Again, you were having 2y here, and you factored y out. So we put this in a bracket because the y at the end will multiply this value to get this. And this same y again will multiply these two to get this, in order for the y to be the subject. That is what we are supposed to do. Now, in this step that we can see that the y is being multiplied by the bracket. So if the y is being multiplied by the bracket, then we have to divide both sides of the equation that we have by the bracket in order to let the y stand alone. So we divide this one, or this term, let me put it that way, this term by the one in the bracket. Then we also divide the x by the one in the bracket. So you will notice that after dividing, this was able to cancel out. Then the y was able to stand alone. Having y or having x, since y is alone, we've been able to make y the subject. Good. X 3kx minus 2. And from the question, we were asked to make y the subject of the relation. So we have successfully made y the subject of the relation by stating that, therefore, y is equal to x divided by 3xk minus 2. Good. When you continue to the II, which is the BII, it says we are to find the value of y using our result. So here, if you come here and you substitute the values to find y, we are wrong, because the question says using our result. And what was the result? The result is y is equal to x divided by 3kx divided 3kx minus 2. Sorry for that. So here with the II, we have to find y. And in finding y, they have given us the condition that when x is -1 and k is 2. Therefore, we are going to put x to be -1 and k to be 2 into our result, which is the y is equal to x divided by 3kx minus 2. What it implies is that wherever we see x in the relation, we put -1. And wherever we see k, we put 2. So we have x to be the numerator. So we substitute the x, we substitute in place of what? -1, giving us -1 divided by 3kx, and the k is 2. So we've replaced the k with 2, and we have replaced the x again with -1. So multiplying 3 times 2 gives us 6. We have -1, and multiplying -1 by 6 gives us -6. So the denominator now becomes -6 minus 2. Then we have y is equal to -1 minus -8, where the negative will cancel out and gives us y to be 1 divided by 8. And that gives us, therefore, y is equal to 8. So for the question 1b, this was what examiners were or expect learners to do in order for them to have the full marks, or in order for learners to be able to have the maximum scores. And also as a learner, that in solving you will be able to give more details in your solution. When I say more details, 2026 is just at the corner. So 2026 is just at the corner. So this was what was expected from candidates when they were writing mathematics. This is BECE 2025 question 1, and learners were asked this to provide their understanding to the lesson for the whole 3 years in JHS department. And this was what was required from learners. Again, ladies and gentlemen, I'll use this opportunity to thank us all, or thank you all, for being a supportive viewer and a subscriber for my channel, helping my channel to grow. And I believe that we've all heard the news that by the grace of God, we have been nominated as a Teacher of the Year by Eminent Awards. I will say, if my service has ever been of help to you, I would plead with you to vote for me so that we can also bring the award home to honor the name of our Lord Jesus Christ. Again, this is the question 1A, I and II. This was what was recommended from learners. Then the question 1 again, question 1B, I and II. Learners were asked to make y the subject from this relation, and they are supposed to find the value of y when they are being given x and k to be -1 and -2 respectively. We'll end it here. When we meet next time, we'll look at the question 2 for 2025. God bless you for staying tuned. See you next time. Bye-bye.